Hello everybody, this is Dr. Pennington. I have a video to show you guys about, this is experiment 7 for chemistry 1152. This is a quick overview of how you guys are going to do the development of the protein standard curve. It's experiment 7. We have a set of protein standards that you guys are going to use. I have them in this ice bath right here. And so there are 6 standards that you guys are going to be using. They're all different concentrations of the protein that we're going to be using. I also have in the ice bath this brown solution. This is called Radford reagent that reacts with the protein to give a color change. What we will be doing is we're going to take a certain amount of each of these samples, 20 microliters, and put them into each of these tubes. I've labeled each tube with the corresponding concentration of each amount of protein, and I'd recommend that you guys label the test tubes in the same way. So what I have here is blank, 0.125, 0.25, 0.5, 0.75, 1.0, and 1.5. These numbers match exactly what's on each of these samples. These are also the concentrations that you're going to put into the spectrometer when you run these to get the absorbance for each. So here's what we're going to do. And bear in mind, these guys are all on ice simply because they're very temperature sensitive, so we have to keep things cold. So, as I said, the first thing we're going to do is to take 20 microliters of each of our protein standards and put them into each of these tubes. The only exception to that is the blank, which is just going to be 20 microliters of water. For that, I'm using this yellow pipette with 200 on the bottom. I have it calibrated to 20 for 20 microliters. Remember, when you're using these, you want to make sure you keep the pipette held straight up and straight down. You don't want to put it down on the bench top horizontally, because that's going to mess it up. So all we're going to do is go ahead and get a pipette tip. If we do this right and we go from least concentrated to most concentrated, we can use the same pipette each time. Okay? So the first thing I'm going to do, I have some water that I put into here earlier. You guys will remember how to use these from the last time you used them in experiment 6. Remember, there are 2 points at which you can push down on the top of the pipette. There is the first stop where you'll feel some pressure, and then the second stop. Remember, the first stop is what you use to pull the solution up. The second stop is when you push down to dispense it to wherever you're going to dispense it. So, for the water, for the blank, I'm just going to push down to the first stop, and I'm going to pull up my 20 microliters of water. Remember, you want to make sure to keep that pipette tip in the solution the whole time. And I'm just going to dispense this into the test tube. 20 microliters, just so you guys know, is a really, really small volume. It's easy to think there's nothing there. Next, we're going to do the least concentrated solution, which is the 0.125 milligrams per milliliter. And I'm going to do exactly the same thing as I did for the blank. I'm going to put the pipette tip in, and I'm going to pull up what appears to be a very small volume of my 0.125 milligram per milliliter protein sample. And I'm going to put that into the tube. And I'm just going to do exactly the same thing for each of these samples. And I'm doing them in order of increasing concentration. So I did the 0.125 first. Now I'm doing the 0.25. Remember that if you do these in the correct order, from least to most concentrated, there's no danger of contamination between samples. All right? So again, I'm just doing this sample by sample, taking it slow, putting each sample in, and then getting that amount of each sample out. This is the 0.5 that I just did. Again, these are very, very small amounts. All right, now I've got the 0.75. You guys get the picture here for what's happening, right? I'm just doing exactly the same thing a whole bunch of times. So 0.75, put the sample in, all right? And I've got 2 left. This is the 1.0 milligrams per milliliter. same thing as before. Each time I'm keeping the tip of the pipette in that protein solution to ensure that I get everything out. And each time I'm dispensing down to the second stop, so I get everything out. Then the last one, the most concentrated solution, is the 1.5 milligrams per milliliter. All right. So at this point, I have all my protein samples and my blank. At this point, I'm done with this tip. So I'm going to put it into a used tips beaker. And we're done with this pipette as well. So I'm going to put this back. Remember, always keep them vertical. The next one is going to be, I'm going to put in my Bradford reagent for each of these samples. This is 1,000 microliter pipette. It's currently calibrated to 1,000 microliters, which is exactly what you want because we need 1 milliliter at 1,000 microliters of Bradford reagent that goes into each of our tubes. Once again, we're going to start from the blank to the most concentrated. I need, of course, a tip. This is the blue pipette. I have a blue tip. The tips are much bigger because the pipette's much bigger. The only difference in this case is that I'm pipetting in the same volume of the same reagent each time. But I'm going to follow exactly the same procedure as I did. I push down to the first stop, put my pipette into the solution, in this case the Bradford reagent, and then I dispense it into the tube that I'm looking to dispense it into. I can use the same pipette tip because I'm using exactly the same solution each time. So I'm going to do this for the second one, and I'm going to pull this up and then push it down, pushing down all the way to the second stop. And I'm going to do this literally for each of my solutions. And the hope is what we will see, and this color change should occur relatively quickly, is that we should see, all right, now sometimes you'll see this happened. Notice there's a big air bubble here. I don't have the brown Bradford solution all the way through, so I'm just going to push it back in. And then I'm just going to try the same thing again. I'm going to pull this up. And I'm just going to put it into the tube again. The overall goal here is hopefully with increasing concentration to see an increasing color change across all the samples. That's the hope. So I just do exactly the same thing for each of these until I have all 7 of them done. All right, I have the same issue again here. So I'm just going to try it again. Keep everything in there. All right, and this is doing the same thing again. All right, one more time. I'm pushing down to the first stop, and I pull all this up. But that may be an issue with me just pulling it up too quickly, that's all. So try and make sure that you pull the solution up relatively slowly. And then the last one, I'm just going to pull this up. See, I get everything there. I think I was just pulling it up too quickly. Put the last one in there. All right, so same as before. Now I'm done with my Bradford reagent. I'm done with this tip. I'm going to put it in the used tip flask and then put this here. Now, the hope is that what we see is a set of color changes where you can see us going from brown to blue. Now, the one thing that we haven't done here is mix any of these together. So part of the procedure tells you guys to use a vortexer. The vortexer is this guy right here. So I'm just going to turn this guy on, and you can see it vibrating like this. Just put these on. It allows you to mix the solutions. It does not take very long. Just mix these up. This just allows for maximally effective mixing, which will hopefully also maximize the color changes that we see. So once I'm done with these, I'm going to have you guys look at these solutions again to see if you can see the color change from left to right. Now, if I put maybe a piece of white paper under here, can you guys see the color change from left to right? We have the blank, which has no protein in it. The amount of protein increase is going left to right, and it's most blue on the right hand side, which makes sense because that's the most concentrated solution. That concludes the first part of the video. Next, we'll show you guys how to run these in the spectrometer.